So far our program prints out a long list of numbers. Wouldn't it be nice if we could actually get a graph? So let's see how we can modify our program to get a graph. Well, first of all, we're going to need to import the matplotlib library. So let's insert a new cell up the top, insert cell above, and we'll import matplotlib.pyplot as plt. Shift enter that. So now we've loaded this matplotlib pyplot library, which allows us to plot things. What we're going to need to give matplotlib is a list of x values and a list of y values. So when we run the loop, we're going to have to assemble that list. Now the way we do this is, first of all, we put an empty list, and then inside the loop we add the numbers to the list. So let's store all the time values, so we'll call it, I don't know, t-list, and we'll set it up as an empty list, which is just open and close square brackets, so that's empty at the moment. And then inside the loop we use the append command. So what we do is we type the name of the list we want to add things to, t-list, and put .append, and then in circular brackets whatever we want to append to it. So what this is going to do is we're going to start off with t-list, which is empty, and then we're going to go through the loop, and each time we go around the loop we're going to add a new value of t. Okay, so let's run that and see what happens. It didn't print anything. What went wrong? Well, the while loop won't print anything only if h is already not meeting the conditions. So somehow h is already below 0 when we start. But we set h equals 300 up here. But what you've got to remember is this is only set when we shift enter on that cell. So what happened was, when we first ran the program, we ran this and then the whole program worked. And when the program finished, we calculated when it reached the ground, so h is less than 0. Unless we run this cell again, it's starting with h already less than 0, so it doesn't go anywhere. So what we need to do is run this cell again, shift enter, and now when we run this, it should work. And we should now have a list. Let's have a look at t-list. So just put the name and shift enter, and it tells us what's in that list. And it's the list of all the t values, so that's all good. Okay, now I'm going to stop printing everything out because it's a bit annoying having all the scrolling down there, so we'll just put a hash in front of this, which turns it into a comment, which means the program ignores it. But it does mean if we want to bring the printing back because something goes wrong and we want to find out where it's going wrong, we can just get rid of that hash and it's back. We've got the t-list, so let's have some other lists. Let's store the heights in h-list. So we need to set up all these empty lists at the start, but we'll store the velocities, v-list equals square brackets again, and let's store the accelerations, a-list equals square brackets. And then inside the loop we need to append all these things. Okay, now that should work. Let's shift enter on that. Oh, that probably wouldn't work because we need to run this first. Now let's run this, and now let's see if we've got, say, a list of accelerations. So yep, we've got a list of accelerations. Okay, now we need to plot it. Now the command to plot is plot, so it's plt for the package dot plot, and we need to first list all the x values, which in this case is going to be the times. So we'll do t-list, comma, and let's say we plot the heights, h-list. And we also need a format command, which tells it what colour we want, what sort of symbol we want. Let's have a line, so we'll put a minus, which means plot it with a line, and we'll pick our colour. Let's have green, so G for green. That's not enough by itself. We also need to show our image. So this creates it and that one shows it. So let's run this. Oh, and there we go. Looking good. So we have the height, starts off at 300 meters, starts accelerating downwards, then reaches the terminal velocity and falls at a steady rate. We can also plot the velocities, so let's get V and run that. So the velocities start at 0, accelerates downwards, then eventually plateaus out at the terminal velocity. And we can plot the acceleration. Acceleration starts off at -g, reduces, and flattens out near 0. Again, as we expected. So that's all very nice. One thing we can see is the effect of making our time step bigger or smaller. So let's say our time step was, well, let's see, how long is it taking? So it's taking 2 seconds. It's changed quite a lot. It takes about 6 or 7 seconds before it's really coming to the terminal velocity. Let's say we made our time step 1 second. What would happen? So I need to run that again, run this again, and now plot the result. It's not too bad. It's not good. It's a bit jerky, but it's kind of fitting. If we made that 5 seconds, so we'll run the cell at the top, then run the cell. Ugh, that's clearly our approximation is crap here. So we need a smaller time step. So if we go back to 0.1 seconds, that still didn't take long to run. So Shift Enter up here, Shift Enter up there, Shift Enter up there. We could make it 0.01 to make it more accurate. So Shift Enter up here, Shift Enter up here, Shift Enter up here, and it looks very much the same. One way of telling when your time step is good is that when you shrink it further, it doesn't make much difference. So clearly, when we go from 0.1 to 0.01, it doesn't make much difference. That's telling you that 0.1 was probably good enough. Now let's make our graph pretty. Let's put some labels on. So we'll do plot.x label, and x is time in seconds, and plot.y label acceleration in meters per second squared. Run that, and some nice labels. And finally we can save the picture in a format that we could use to glue into an assignment or something. So we need to put plot.savefig and the name of the file, and the extension on the end tells it what format to do. So let's call it, I don't know, basejump.png. So let's save it as a PNG file, which is a good general purpose format. And we need to set the dots per inch equals 300 to make sure the image comes out nice and high resolution. Okay, Shift Enter on that. And we'll see this has been dumped in whatever directory our program was in. If we go back here, this is the directory, and we can see basejump.png. It's in the desktop. And let's have a look. There we go. Very nice.